Alright, so we are in chapter 11.2, and we are really going to talk about these properties here. We are just going to lay the rules for them. We are really going to use them in the upcoming chapters. And so we're just going to lay the groundwork for this. We're not necessarily going to be doing too much with these rules. We're just going to be practicing using the rules. We're going to actually show how to use the rules to solve equations more later on in this chapter. For this section, we're really just, like as she's going to say right here, we're just laying the ground rules. We're setting some ground rules. We're setting up some stuff that we need to know. So I'm kind of go quickly through these. The thing you need to know is it says the zero property of logarithms. Anytime you have a logarithm of 1 with any base, it's always equal to 0, because if you have log base b, right? If you have b to the 0 power equals 1, what is this b going to be? It's going to be anything. Anything right here, base anything to the 0 power is always going to be 1. Anything to the 0 power is 1. So whenever I have anything and the argument is a 1, I know it has to equal 0. It is called the zero property. So the logarithm of 1, so any log of 1 with any base is always equal to 0. So if I have log negative 2, 1, that would equal 0, because negative 2 to the 0 power equals 1 all day. Alright, so that's called the zero property. Alright, the next thing we need to talk about is whenever you have, and they call this, they talk about this, refer to this with as the logarithm with the same base as the same argument. So right here, if you notice, you got the same base and the same, remember this thing is argument, it's always going to be equivalent to 1, because if I have log 1,000 and I want it to, the argument to be 1,000, that means 1,000 to what power is equivalent to 1,000? Well, 1,000 to the first power. So that's the argument and the base are the same. Argument and the base are the same. It's always equivalent to 1. So those are two properties. This one is called the zero property, and this is just the log with the same base and same argument. All right, now we're going to get into some other properties. So what happens when we have this thing called the product rules of powers? We're going to get to this down here. Here's what you need to know, the product rule for logarithms. This is the rule that you need to know right here. And remember, please remember, these rules go both ways. So I can go here or I can go backwards. At times, we will want to use this rule this way, and at times we are going to want to use it backwards. So anytime you have something where you have the log with base b, so if I had log base 2, and this is 5x, so that's 5 times x. I could rewrite that as log base 2 of 5 plus log base 2 x, and I could write it like that. And then that's what this rule is stating right here. And not only can I go this way, but I can also go backwards. So that is called the product rule. We need to make sure we remember that. Again, like I've said, we're going to use this more later on in this chapter. Right now, we're just setting the ground rules so we understand how we can manipulate these things. Remember in math class, always changing the way things look, not changing their value. And here's some of the ways that we can change the way some logarithms look. This one is called the quotient rule, and it's very similar. Think about it. When I had x to the second power to the third power, right? When I had that, when I had x to the second times x to the third, I added these two guys. When I had x to the second divided by x to the third, I subtracted these two guys. Well, think about this right here. If I have a log in its division, it turns over here into a subtraction problem, very similar to the multiplication one. And notice this is very important. No, the bigger one does not always go first. The one that's in the numerator goes first. The one in the denominator goes second. Okay? That is called the quotient rule. And again, it's something we're going to use to manipulate these equations later on. All right, now this is more along the lines of the power to a power. If we have, so this is written with, you have a log base b, and you have an argument here, but your argument is to a power. What you can actually do is you can bring that n out to the front, and you can say, you know what, if you just did the log bx, you could just times that to the nth, whatever that nth power was. So like, just to give you an example, if I have log base 5 x to the 7th, that's the same thing as 7 times log base 5x. So what I could do is I could find the answer to this and then multiply it by 7. And again, please remember, not only does this rule, any of these rules, they do not just work this way. They also can be wrote this way. So if I give you this, you can rewrite it back into this version where you take the 7 and pull it from here up to that power like it is written there. So please remember that, because we are going to go back and forth between these different rules. Sometimes we're going to use the forwards, sometimes we're going to use it backwards. So here are some of the examples of zero property, and they give you some of the log. So this is exponential. This is what it means in exponential. This is when it turns to logarithmic. Okay, so there's a zero property that we just talked about. The same base, because this is b to the first power is just b. Well, if I have log of b with the argument b, I know it has to be the first, because remember these two things are, the same, because this means really b to the first power equals b. They're just changing it from logarithmic to exponential, or from exponential back to log. These are just the rules that we've talked about right here. This is what it looks like when you have it in exponential for the product rule. We talked about same base. You add the exponents. Okay, they both have the same base right here. Okay, and so then what it just becomes is you've got x plus the log base b, x plus log base b, y. Just like this, where you add the exponents. And then you have the quotient rule where you divide them. So now we're going to actually go ahead and just play around. We got the product rule again. You can pause the video and fill these charts, and there'll probably be something for you to go back to look at. But all I need you to know is when you get this, you can change it to this, or when you have this, you can change it back to that. And there's some real examples of what that should look like. And here, if you notice, they rewrote, in this problem right here, they took log base 2, and they rewrote the 27 as 3 to the third power, and then they took that 3 and moved it in the front, and that's how they got this answer up there. So please make sure you're seeing all that. Remember, again, in math, if you can rewrite, if 27 is equal to 3 to the third power, then you can take the 27 out, and you can put the 3 to the third power in, and then that's where this thing comes from. So that's all we're doing in math, is we manipulate numbers. Change the way they look. Okay? So here we go. We're going to just use some properties. Again, you might want to try some of these on your own for problem 2. You're just using the properties. See what you can come up with. Maybe I'll go over problem 1, pause it, since that kind of makes sense, then try part B. Okay? So what happens is with this guy, I can use a couple things. First, I want to use that product rule. So I'm going to break the 6 and the x to the 5th up. Notice the 6 and the x go together. So if I was doing this problem, it would go log 4, 6 plus log 4 x to the 5th. And then once you have this, you have something to the power rule. That's the power rule. So what we can do is we can pull that 5 right here, and that's where they get this answer from. They pulled that 5 forward. So then you still have log base 4, 6 plus, now the 5 is there, so 5 log 4x. Notice that 4 with that base stays here and there, okay? So then here's some more of the answers, some more things that you can go through. I'm going to try to keep this video short so you can pause it and kind of look through it. But again, if you notice what they do, when you multiply the 3 times the y, that's the addition, right? Because that's 3 times y to the 4th, so I can break that up as addition. The division one becomes a subtraction, okay? The y is to the 4th, so I've got this. Got log 7, 3 plus log a 7 y 4 minus log 7 x to the 3rd. And then what I can do is I can bring this 4 forward. I can bring this 3rd to the 3rd power forward, and that's where they get this answer from. Now notice with this, all they did to try to throw you off is just use ln. Remember, ln is the same thing as log, but we know that its base is e. And so I don't write log, I write ln. And so same thing, same rules, addition between all of them, pulled the 3 down and wrote that there. Now they're going the opposite way. Now, so up here you started with a single log, and you wrote it and you broke it out into a, everything that you could break out. Well, down here, they're starting with it all broken out, and they want you to change it to a single. So what you're going to do is, the only thing that you got to make sure that's really important is this base has to be the same. And that is a base 2, and this is a base 2. So all my rules, sorry, my pen is off. All my rules apply. So what I can do is if I have log 210 plus log 2x, I can first say, hey, 3, you go up by that, right up there. So that becomes a 3. So I've got log base 210 plus log base 2x to the 3rd. So I just pulled that 3 up to the power. Then I know that this is a plus sign, so when I plus it, I know that that's log 2, and these guys are going to multiply. So it's going to be 10x to the 3rd. Remember, the 3rd only belongs to the x, and so that's where they got this answer from. And that's basically all they're going to do for the rest of these. You can look through, try. Again, my encouragement is you pause the video for just a minute, try some of these, and see if you can come up with what they're doing. Again, you want it to be written as one logarithmic, so you got to get it all together. This C is probably a very good example. I'll go through it. What you're going to do is this 3 right here belongs to both those ln's. So that means you're not only, this ln is going to be ln 3 to the 3rd minus ln x to the 3rd, right? And all of that times or plus ln x minus ln 9, right? So what happens when I have this minusing right here? I've got to take care of these. Since this is in parentheses, I've got to take care of this first. And when I subtract these two, it becomes a division problem. So I get, sorry, I'm going to write over here, ln 3 to the 3rd, which 3 to the 3rd, so I would actually write this out as 3 to the 3rd would actually be 27. I would sorry, dang it, this thing didn't record. So right here, this should have been ln. What I wrote so far is I just took 3 to the 3rd power, which is 27. That's where this came from. And this is x to the 3rd. And since they're subtracting, it's a division problem. And I would actually do the 3 to the 3rd out, and I would leave that x to the 3rd with it. I don't like the way they wrote it down here. That seems confusing to me, the way that they wrote it. So hopefully my explanation will help you out. Then I'm going to worry about this part, which is ln x minus ln 9. So I know since it's subtraction, it's going to be x over 9. And since these two guys now are adding, I know it's going to be ln 27 x to the 3rd times x over 9. And I can simplify, I can cross-simplify this. I go, wait, 27 and 9, one's in the denominator, one's in the numerator. 9 goes into 27 3 times. 9 goes into 9 1 time, so that simplifies. There's an x up here, so that would simplify to a 1. I take one of these x's away, I still get x squared down here, so then that's where they finally get ln 3 over x squared, and that's how I would do that problem. Remember, if you have any questions, make sure you see me tomorrow. We're going to practice these and go over this. Whenever they do these types of problems, they're trying to rewrite this using, since they give you this right here, and since they give you this, and since they give you this, you want to rewrite any of these logs using only those numbers. So if I was doing this problem, I take the 50 and I want to rewrite it using 5s, 2s, and 3s. And so what they do is they say, hey, you can break a 50 up into a log A, and what you can make 50 is you can make it become 5 times 5 times 2, because 5 times 5 is 25 times 2 is 50. So again, remember, I rewrote, this is really 50, so I haven't changed how much this value is, I just changed the way it looks. And then what they rewrite there is they say, hey, wait, 5 times 5 is really 5 squared, so that's where this picks up. And then when you have two things that are multiplied, you can write it as the addition of the two. So they wrote, if it was me, right here, I would have actually wrote log A 5 squared plus log A 2. And then what they do right here is they say, hey, let's pull this out forward. And so that's where they get 2 times the log A 5 plus log A 2. And anytime you see this right here, it's represented by a P. Anytime you see this right here, you can replace it with an R. So they did what's called substitution. The 2 stays there, so you have 2P plus an R, and that's where this comes from. So these are very good examples. So if like I said, if it was me, pause the video right now, try some of these. Remember, you are manipulating math. You are changing the way, so you're changing the value, not the value, you're changing the way it looks, not the value. So again, like I said, you want to change 50, and you want to use 5s, 3s, and 2s. You're going to change 0.3, and you want to use 5, 3s, and 2s. And if you see right here, they broke 3/10 and they made it a fraction, 3 over 10. They make 3, that's good, I've got log 3. They make the 10 a 5 times the 2. They don't do a very good job of showing that. But really, the next step is they say, hey, wait, this really is log A 3 over 2 times 5. And when you have the division, right, 3 divided by this, there's the subtraction. And then the 2 times the 5 is the plus. That's where it comes from. And then they replace all those with the numbers or the letters that they are equivalent to. All right? 27 can be written using 3s. And so that's what they're doing. So go ahead and try those examples. And if you can get those and just understand where it's coming from again on tomorrow when you come in, we'll practice this. But these are just the rules. We're going to really use those rules later on. So it's very important. No, we probably necessarily won't use this too much, but this is a way to practice using the rules. And when we get to solving equations, we're really going to use the rules big time. So it's just help you to get there. All right, have a great night. See you tomorrow.